Pseudocode. Pseudocode shouldn't be scary. On the contrary, it's meant to help you think about how your code or program should run. It's literally programming your code, but in a different syntax. And I'm going to help you go through that syntax today. Hey guys, I'm Uche, welcome back to the channel, and yeah, I'll be walking you through Pseudocode. Again, probably last minute for BTECers. If you're doing the BTEC Level 3 Extended Diploma or National Diploma in Computing Level 3, Unit 1 or 4, or just someone who's curious about algorithmic. Algorithm.
A little longer than a few minutes later.
So let's get right into it. Pseudocode. We'll start with variables. Oh, I forgot to mention. At the beginning of your code, you must start with begin and end it with an end. Capital letter, capital letter. That's another thing to know about pseudocode. So, oh sorry, I rushed. Let's take a breath. First thing, begin with the keyword begin. And at the very end of your program, end it with end. I think it would be safer because I assume you will be typing it in, let's say, Microsoft Word or text or Notepad or whatever text editor you use. Start with begin and end, capitalize them, and then, with the blinking thingy cursor, just right in between so that you don't forget to put end at the end. I hope that helps. That's what I do. Okay. Another thing to know about pseudocode is that all your commands and keywords must be capitalized. Each and every one of them must be capitalized. So, like with begin and end, we're going to capitalize everything that involves our variables, which is where we're going to start with. So what are variables? Variables are containers for values, essentially. Things that store values. Could be inputs, could be a local, it could be, it stores values. It could store them temporarily and it could store them throughout the program. And I think there are two types of ways to containerize a value in programming. We've got variables and we've got constants. So it's one thing to have a variable, it's another thing to have a constant. What's the difference? A variable, that value in that variable can change. So it's giving a value a name. So let x be 0. So what is 0? 0 is x and x is 0. The name of that variable is x and the value of that variable is 0. So let's say let x be 0. Let x be 0. And when it comes to pseudocode, these texts, they're not strictly it must be let or it must be no. I personally use initialize x to 0. That's also good. What matters is these two are capitalized. So let x be 0. This is the variable name and this is the value. Okay, so another thing to know about variables is the case you use, your casing. That's the naming convention you decide to use. I think there are two main cases I know of, CamelCase and snake case. Naming convention is just simply how you name your variables. Choosing to name them, giving them like a meaningful name, and don't just give it like, oh, x be 0. No. If let's say you're doing a program that that takes two numbers and does some operation between those numbers. When you are naming the variables to store the values of such numbers, it would be ideal to name them something sensible, meaningful, and something another programmer could read. That let's not just name them X and Y because we're trying to be quick. No, for pseudocode or even in your program, I think it's much more efficient to use a decent name that is meaningful and uses a naming convention. What do I mean? So I could say let number 1 be 0 and let number 2 be 1. This is CamelCase, this is SnakeCase. Okay? And in your program, do not do it like this. If you are using a case for something, use that casing throughout. If I am using camel casing, I am using camel casing throughout. So if this were in my program, I would have lost marks because I use 2 different types of casing. That goes against the consistency rule. You have to try to be consistent when you are doing pseudocode and even your code. Now, we've got variables, but then we've also got constants. Constants, now, on the other hand, I think would be much more preferred to have, they have a specific naming convention, which so happens to be a programming thing, a programming convention by some programmers. Not fully necessary, but I would recommend doing this. So you capitalize the constant, the name of your constant. I wouldn't call a constant a variable because it's not a variable. A constant and a variable are 2 types of the same thing. They both store a value inside some container, but there's a difference. A variable stores that value, but it could change at any time in the program. But a constant, it stores that value till that program ends, until that program ends. It doesn't change during when the program is running. So that's the difference between a variable and a constant. And noting these 2 in your code and pseudocode is very important. So I know I said be consistent, but it takes a different toll here. So since constants and variables are not the same thing, essentially, it would be nice. It's okay not to give them the same naming convention, but it's worth being consistent in the naming conventions of constants and variables. So if I'm making a constant throughout my program, it has to be capitalized and it's going to follow SnakeCase. And then while my variables will follow, let's say, CamelCase and normal CamelCase. So let me give you an example. So let's say let minimum age be 1. Let maximum age be 0. Oh, that's not sensible, is it? 10. See that? Capitalized SnakeCase. Good thing to know. A plus would be putting a comment above your thingy and telling the person reading it that, oh, these are constants and then these are variables. What else have I just taught you? Comments. I just taught you how to comment in pseudocode. So in pseudocode, to comment, it's these 2 slashes, forward slashes, and then, so this is commenting in pseudocode. So yes, you can comment in pseudocode. Essentially, pseudocode is literally programming, but it has its own different syntax. Okay, so that's it about variables and constants. You've learned the importance of capitalizing all your keywords and commands, the cases, SnakeCase and CamelCase, and you've learned the difference between a variable and a constant. And also that you could give the 2 of them separate naming conventions in your program or pseudocode. We will move to inputs and outputs. Inputs and outputs. Inputs are a way the user can write in data into your program. Outputs are the way the user can see it. It's quite straightforward, but again, consistency still applies. So let's say I'm making a program. To ask the user for their age and their email address. I'm going to output it's more sensible to output bracket the message that the user is going to see. What is your name? Input name. That's it. That's it. I think in Python you could do like this. Whereas the message inside the function is doable. I think I've seen it somewhere that this is acceptable pseudocode, but again, consistency. If you're going to do this throughout. If you're going to do this throughout. Okay? Whether you're wasting time or not, it's better to be consistent. So, yeah. I think this one is better because they get to see that you know that the user is meant to see this first and then they input your name afterwards. All inputs are expected to be string. So that's how you do it. Input and output. Now, I know some people might be like, okay, I use print or I use display. Whatever it is you're going to use, be consistent. The marker is not going to be happy if they see display. What is your password? What is your email? That's what we were doing. What is your email? Input email. They are not going to be happy to see this. No, they are not going to be happy to see that because you are not being consistent. So it has to be output. If you're using print, it will be print throughout. If you're using display, it should be display throughout. Consistency. Okay, that's it for inputs and outputs. And then we end. Finish. Okay. You've learned inputs and outputs. Now we'll be going to the bits, the true programming paradigms. Who can remember the three main programming paradigms? Oh, never mind that. Who can remember the three main programming paradigms? Comment below if you can before you continue, because I'm going to say them anyway. Maybe tag the time. I think you can do that now. Just cool. So yeah, the main things are sequence, selection, and iteration. Sequence, selection, and iteration. Sequence involves how you arrange your code. This is the first thing you have to kind of think about if you're not thinking about variables, inputs, and outputs. And then selection is your everyday if statements, if and else statements. I now know that there are other things we can use to perform a selection, and there are smarter ways to go around it. But for now, the main thing is the if and else statements. There's also the switch case, also another thing. But the main thing for now is if and else statements. And then iteration. Iteration is, I think, the tricky bit, the really, really tricky bit. Because there are lots of them. There are lots of them in pseudocode, but then the weird thing is, in different programming languages, they become less and less. I think Python only has like a while loop and the for loop, but then in C# you've got the while loop, a different sort of for loop, and then you've got the do while loop. In pseudocode, however, I think there are four main ones. Precondition, postcondition, and then the one that's not really conditional. So you've got do while loops, you've got repeat until loops, you've got while loops, and then you've got the for loops. These are like the four main ones. Each one has, I think, two of them are kind of similar. I think repeat until and while loop are kind of similar in some sense. Do while loop allows you to do something while a condition is being met. But then repeat allows you to do something until a condition is met. While a condition is met, so this one is kind of, so while a condition is met, and then the for loop. Sorry, I'm confusing. I'm being confusing for a bit. Just don't mind that. Just know these are the four iteration types. We're going to learn how to use all of them. Now the thing to note is for iteration, these ones, because this one is the one that doesn't depend on condition. It doesn't depend on any conditions. These ones do. It's do that while something is running. Repeat that until something is met. And while something is true, do something. So essentially this, you could say this is a while do, while this do that, but while loop, essentially. We're not going to look at how to do that in pseudocode. So sequence is, I think, more or less a way of thinking than it is a real programming paradigm, but it is something you have to think about. For example, I wouldn't print a name that I haven't asked the user for first. Sequence. Or I can't print out an operation being done on variables that I haven't initialized. Sequence. That's the thing to think about. Some programming languages are more strictly sequential than others, but you get the point. You know, some things should be done before the other. And for the exam, your client brief should give you a good structure of how that should be like. There are certain things you have to do before certain other things. Certain things have to come in certain order. Yeah. So that's sequence. It's essentially a way of thinking. Yeah. So, I'm thinking of a scenario. For a program that expects us to, okay, let's just use one of the ones we've had already for this. I can't do this first. Sorry. I can't output their names first when I don't have their names first. If that makes sense. You know, this can't be the first part of my program. It'll say, oh, what is this? You haven't asked that. You can't put this first. Or just swap them anyhow. There's an order to things. It has to be sequential. Selection. Selection, if statements, conditional statements, if and else statements. Selection is a programming paradigm that lets you perform an operation based on a condition being met. So these are used for validation or just to achieve different parts of your program. So let's say your program asks you to display a certain text when a user is above the age of 75. So let's start. Begin. Output, what's your age? Input age. This is also, indentation follows quite strictly, and there's you'll see how it is done. So it's going to be if age is greater than 75, then no semicolons, no this, no, none of that. We're not having any of that. So it's if age is greater than 75, then indent. This is a major thing. So you indent for when you are trying to perform what a program will do when it's going to meet a condition, or for every iteration, or for these two things essentially you indent. because it shows that, oh, it's going from, if this is going to happen, you indent, and then let's say you output, you are lovely. Yeah? And if. This is also another thing. And if must be there. We've got the same thing for while loops. So you say while a condition is being met. So let's say while age is less than 5 or something is less than 5, indent, output something. This is an indent. Output something. Age plus plus, age increment, and while. So if and while have the same thing. The same thing happens with functions, but I think let's not jump into that right now. So yeah, if, while. For has a different approach. So let's say for I equals 0 to a number, let's say 5. Then indent, output, yeah, let's say. Next, I. It shows that logical flow. So if the condition, then what happens, and if. If you're going to do else if, kind of same thing, else if, indent, else if, don't do else and or and else, no, it's just and if, and the if statement. It's one full if statement, even if you've got else in between. And for the for loop, this just tells your program, okay, I is going to be 0, it does this. I is going to be next I, so I goes to 1, that sort of thing. And then repeat until is quite self-explanatory. Repeat, output yay or output nay until a condition. Note the indent. Note the indent. Note the indentation. That this line I'm giving just signifies indentation. Another thing to note is you indent also after the begin. So say end. See it? Begin, indent everything in between begin and end. And it just follows that sort of structure. So you indent when you are writing a statement for what happens to a condition. For per iteration you indent. Per iteration you indent. Per iteration you indent. Per iteration you indent. Per condition you indent. So that's it for processes. I think I've covered both sequence and iteration at once. The Pseudo-code bit, I'm not teaching you how to think logically. I'm teaching you the essentials for Pseudo-code. Note the indentation. I'm going to do a final example to sum it all up, and hopefully in another video, because this is, I think, taking way too long, we're going to look at data structures for Pseudo-code. Okay, so how to bring this all together. I'll make a program that asks the user for the age their age, their name. At the end, it will output these things. There will be a condition for each age, and then it will print out a letter which resonates to the number of their age minus 10 if their age is less than 10. That's quite complicated, but let's do it. Okay, so what do we need? They needed the name, they needed the email, oh no, they needed the age. There needs to be an age check, I think. There was an age check. I said there should be an age check between, let's just do lesser than 10. It's not allowed, so we need people that are greater, we need people that are greater than 10 years old. There was no maximum. And it needs to print out the first letter of their name, the number of times of their age subtracted by 10. Okay, let's go. So begin, indent. Don't do the dash thing and just indent, like give space. And so output, what's your name? Input, name. Output, what's your age? What's your age? Input age. Age is going to be a string, so kind of need to validate that, because every input takes age as a string. So I think I'm going to convert it to an integer to, okay, no, sorry, it's a.int for pseudocode, or integer. So the marker knows what I'm doing. Now, if age is less than 10, then indent, output not suitable for program. Else, the rest goes onto here. Else, we're supposed to print out the first letter of their name. So I need something to get the first letter of their name. I think it's okay. No, it's not okay if I use first letter of your name. Mind you, I have not done any validation checks here whatsoever, so that's also something to put in mind when you are actually programming and writing your pseudocode. It could come like after or at some point, because here the user could still enter nothing, and it will continue with the rest of the program. So that's something to look after. Okay, back to where we were. Else, I should have started with this. So this assumes that you're going to use a computer or text editor to write your program. It's not going to be truly strict. I need a variable. I'm going to move you there. I need a variable, and that variable needs to be first letter. I'm going to declare this because right now I think I'm just gonna do that so I can use it here. First letter is equals to, you can index the first element of a name. A name is seen as iterable, so that's from string manipulation. So essentially this means it takes the first letter of the name already. I don't have to do much to get to that. It's just string manipulation, and yeah, it's allowed. I think I'll do this in the second video about like data structures and like other bits like random math functions, file handling, and also maybe try and catch, and maybe also validation, maybe. But this is the essentials for pseudocode, how you should think about pseudocoding, indenting, and the basics in that. Let's continue. First letter, so this already takes the first letter of her name. And then we use, what should we use? A for loop. We could use the other types of loops too, but we just might need to be careful. So I'll use a for loop for I equals 0 to how many times? Age minus 10. Okay, I might need to make another variable. Declare needed number. Needed number equals to age minus 10. Age minus 10, and then I go with a for loop. See, it's all indented. I don't bring my for loop here or this here. You know, it follows that direct indenting. For I equals 0, no, 1 to needed number. Then prints their name, age. Output first letter. Next I. And then we end the if statement. And if. I think that ends the program because we've achieved the client requirements. So we can end the program there. So you see that? Indent everything in between begin and end. For this if statement, note this is meant to be under the same indentation. This is not an indentation. This is just, so it's all under the same thing. But then I indented if, indented, indent, indent, and further indented what was from the for loop. So yeah, this is a sample pseudocode and shows what you should be looking for in your pseudocode. So if not anything, know this: consistency, naming conventions, how to indent. You indent per iteration. This highlights per iteration, or per operation for a condition. So else condition, else means anything other than this condition not being met, this will happen. So what happens per condition? What happens per condition? Indent. And what happens per iteration? You indent. Let me clear my linings so it becomes clearer. Okay. So quick take-home assignment, and I'm going to look at this in another video. Try to do, I will highlight a link about it later. Try to do the April/June paper for 2025. Pseudo-code. You can do the code first, up to you. Oh, I forgot to mention, another pro tip. People that are good at code, you can always just do the code, finish it, and then you can just translate to pseudocode. Remember, pseudocode is essentially writing program, but with a different programming language. So you could do that, and it also makes sense. But keep in mind the rules I said: the capitalizing each keyword and command, consistency in spacing, consistency in naming, consistency even in using comments. That's it for today, all about pseudocode, and I will catch you in the next one. Bye.